I'm Kathy Holloway. I'm the Academic Director of the Global Disability Innovation Hub, and I lead this TIDAL Network Plus grant with the gang that's here. So, Lance, I'll let you finish your cup of coffee, and I'll come to you first. So, Los, do you want to say hello? Feel free to put your videos on, guys. If you don't want to, then don't, obviously. Los, go ahead.
Yeah, thanks, Kathy. And apologies for giving you all an image of me slurping my coffee this morning. My name's Lawrence, or Loz Kenny. I'm Professor in Rehabilitation Technologies at the University of Salford, with interests in the design and particularly the real-world evaluation of devices, including upper limb prosthetics, functional electrical stimulation systems for people recovering from stroke, and more recently I've been working with other colleagues here, including Disabilities, on the area of walking aids, and I'm one of the co-investigators on TIDAL.
Brilliant. Arjen, come to you next.
Yes, of course. Good morning, everybody. Thanks for joining us. I'm Arjan Buys. I'm a reader in biomedical engineering at the University of Strathclyde and an honorary professor at the University of Rwanda. Just for the information, I'm also a registered prosthetist orthotist, and I'm the clinical lead on this network. My interests are assistive adaptive rehabilitation technologies, and then on a global scale. That was me.
Thank you. Richard.
Hi everybody, my name is Richard Bibb. I'm Professor of Medical Applications of Design in the School of Design and Creative Arts at Loughborough University. I've got a background in industrial and product design, specialising in custom fitting medical devices since about 1998-ish, but my particular technical expertise is in additive manufacturing.
Thanks, brilliant. Mika?
Yes, so my name is Miko Correa. I'm a professor of design innovation at Loughborough University in London, which is at Queen Elizabeth Olympic Park. So my background is in design, but a lot of my work has been in humanitarian work, in post-war reconstruction, things like that all around the world, outside of the comfortable Western context. And I'm very much involved with the design and disability and design innovation program that we're running together with UCL and London College of Fashion. That's me.
Thank you. Richard, have I come to you? I'm going mad.
Yeah, you've done
me. That's all right. Sorry, thank you. Thank you very much. Mark, so we have some speakers today, Callum, Arne, Mark and Sinead. So maybe we'll just quickly, maybe we'll come quickly to you guys and then we'll let everyone else introduce themselves. So those of you that have just joined in, Kevin, we're just doing some soft introductions while we wait for 10:30 start. So Callum, I'll come to you first.
Hello. Yeah, my name's Callum Watt. I'm a research associate with the University of Salford, and I'm working with a company called NRS Healthcare, who's a rehabilitation product supplier. So I'll be speaking on behalf of them today and discussing what we do. Yeah.
Thank you. Sinead, would you like to go next?
Hi, I'm coming to you today from the National University of Ireland in Galway. So I'm currently a lecturer in engineering here at the School of Engineering. And so I do research in sustainable engineering and sustainable manufacturing and sustainable business. I have a background working as an engineer in the medical device industry and as well as a sustainability consultant. So that's me.
Thanks, William, Sinead. Mark, come to you, and then Arne.
Hello, I'm Mark Miadovnik. I'm a Professor of Materials and Society at UCL. I've worked with Kathy and the Global Disability Hub for a long time, looking at the materials issues around devices and manufacturing issues. I'm also the lead for the UCL Plastic Waste Innovation Hub, and in that capacity, I'm going to talk today about recycling and reuse and repair in terms of products.
Thank you. And Arne.
Yes, hello. My name is Arne Eide. I'm Chief Scientist at SINTEF. That's an independent research institute based in Norway, and I'm based in Oslo myself. I'm also a professor at Norwegian Technical University in Trondheim. Main research interest is in disability statistics, but I've been involved also in many projects and initiatives around assistive technology, working with the WHO in particular. And I'm going to talk about the Norwegian system today and focusing a little bit on recycling, reuse. Thank you.
Thank you, Arne. And as part of TIDAL, obviously, the idea is to develop a network and get to know you guys as well as you get to know us. So I'm going to come around. You'll, of course, keep jumping around my screen. So I'm going to do my best to come to everybody. But if I miss somebody, it's because people have moved and people have joined. It's not because I didn't want to hear from you. So just do put your hand up at the end if I do miss you. So I'm going to, just from the top of my screen down, Valentine, you're first. Would you like to say hello?
Hello, my name is Valentine. I'm a PhD student at the French Engineering School in Lyon, and I'm doing my thesis with NGO Humanity and Inclusion. And I'm working on a 3D print prosthesis and orthosis made of local and recycled material from Africa.
Marvelous, thank you. Thank you for joining us. And let me see, Ogbonna, have I got that right? Correct me if I'm wrong.
Yes, you're right. Good morning.
Good morning.
Yeah, that's my local name. I am based in the UK here. I am a senior lecturer in my university in Nigeria. I am a mathematician by training, so I took interest in the aspects of medicine and biomedical engineering, where I finished my course in the University of Dundee. So since then, I've had a couple of interests here and there. So when this came up, I also indicated my interest. I have done something about hyperbaric oxygen therapy. So I was thinking that that could be an assistive technology as well. Plus my interest in designs of hip implants, the bone plates and things like that. So I have interest in these areas. Thank you.
Well, thank you for joining us. It's lovely to have people who are not from the assistive technology space come along. So this is great. Sibylle, sorry.
Yes, hi, I'm Sibylle Thies. I'm also from the University of Salford and have been working there with Professor Kenny for quite some time. My background is biomedical engineering. I have a particular interest in walking aids and making them fit for current living, really, because there hasn't been much innovation in that sector. And I'm also working with Colin Watt, who is speaking later today, as I am part of the KTP with NRS Healthcare, where we are developing a new walking aid.
Brilliant. Sibylle, thank you, Sibylle. It's great. I've known Sibylle for quite a while now, and so it's lovely to have you here. David, would you like to go next?
Hi, good morning, everybody. I'm David Mayman. I'm a lecturer in psychology and chartered psychologist within the School of Sport, Exercise and Health Sciences at Loughborough University. The reason I've come today is because I have a specific interest in older adults with hearing loss, and I've done a lot of work trying to get older adults to engage with hearing aids. So I read a sentence earlier this morning saying that around 80% of older adults with hearing loss don't use hearing devices. So I've done a lot of work looking at smartphone connected hearing aids and other devices like that. And I also am very interested in getting older adults with hearing loss as well as physical disabilities such as manual wheelchair users to engage in physical activity as well.
Fantastic, thank you. Saul, come to you.
Hi there, my name's Saul Albert. I'm a lecturer in the School of Social Sciences and Humanities at Loughborough University, and I'm also co-chair of the Applied Cognition and Interaction and Technology Group at Loughborough with David. So we are working there in a kind of interdisciplinary hub for people basically looking at all kinds of assistive technologies, specifically for cognitive impairments. And I've just finished a British Academy project looking at the use of voice interfaces, specifically in smart home and smart home care situations. My focus is on interaction, so I kind of look at the distributed activities of informal and formal care support workers, as well as their uses of these sort of modular voice interfaces and smart home systems. So that's the kind of thing I'm hoping to look at here.
Brilliant, thank you. It's great to have you here. Ksenia. Let me get that right. Help me.
Hello, Ksenia. J silent, so it's a bit tricky.
That's okay.
Nice to meet you. And I'm a lecturer at the Institute for Design Innovation with Miko, where I do research on sustainable and inclusive services, the design of the services. And I co-lead a project on addressing loneliness through the design of trustworthy autonomous systems.
Oh, cool. Very interesting. Thank you, Ksenia. Kevin.
Hello, I'm Kevin Easton. I'm from a SME called Fortuna, who I'm standing in for my wife and co-founder today, who is an assisted technology clinician with the NHS. She and I have developed a new type of vehicle format, a small wheelchair format, which is intended to address the amount of abandonment that is rife with current mobility aids. So we've got the most convenient and lightest and most agile new vehicle for all those people like me. I'm a wheelchair user as well, who cannot stand what's already on the market. So that's what we're doing, hoping to learn a lot today.
Thank you, Kevin. Come to you, Colin. We're just doing introductions for those who have joined here at a softer start of 10:15, so there's a bit of a mix up in timings. Colin?
Good morning, everybody. My name's Colin Venters. I'm a reader in software engineering at the University of Huddersfield. I'm currently the director of the Centre for Sustainable Software Engineering. I'm also a founding member of the Sustainability Design Alliance, which is an international collaboration between several of who are now mainly my friends from across the globe. I'm co-author of the Karlskrona Manifesto, which maybe some people have heard about, which argues about sustainability design. My principal research is on sustainable software engineering, principally from a software architecture perspective for pre-system and post-system understanding.
Fantastic, thank you, Colin. For those joining, we're just doing some intros. People are jumping, so Khaled, come to you.
Good morning, everyone. Good to see you all.
Audio is breaking up slightly, Khaled. As in, we can't hear you.
I'm Khaled Gohar, Associate Professor of Engineering Mechanical Design. Can you hear me?
Yeah, can hear you now. You come back.
Oh yeah, okay. Okay, my name is I'm Khaled Gohar, Associate Professor of Engineering Design at the University of Nottingham. Background in mechanical design and automatic control. My special interest in use of soft robotics to design and develop adaptable prosthetic devices and multi-purpose assistive technologies for older adults. So good to see you all today.
Excellent. Lovely to see you too. I'm going to keep going with these intros for a couple more minutes, just so that everyone gets to say hello to each other and people can catch up on the videos. For those people that are just joining, maybe I'll give it a second more. We've just been doing some introductions because a few people joined early because there's a mix up with timings. But you can always go back. The recording will be shared with everyone, so you can catch people's intros if you missed it. So quickly, come to you, Mario, then Christos, then Praminda.
Hello, so I'm Mario Giardini, biomedical engineer, University of Strathclyde, working mostly on instruments and devices for community medicine and with quite some experience now both in high-income and low-income countries for instrumentation, mostly for screening diagnostics.
Thank you, Mario. Christoph, oh sorry, we have Christoph.
Yeah. Hello.
Federico, sorry, people. So go ahead.
Good morning. My name is Christos Kousidis. I'm a senior lecturer at the University of West London in the sound engineering department, and I'm working with a research group I have with some PhD students in biomedical acoustics, where we're actually working in some devices, assistive devices, and this kind of thing. So yeah, thank you. Good morning to everybody.
Good morning. Praminda?
Good morning. I'm Praminda Caleb Solly, Professor of Embodied Intelligence at the University of Nottingham. I would like to join this meeting with my startup hat on. So in 2020, started a company called Robotics for Good, a community interest company, which provides assistive robots as a service. Thank you.
Brilliant, thank you. Federico, then we might have to move on to the main part, but let's go. Federico?
Good morning, everyone. Thank you. My name is Federico. I'm a research associate. I'm doing my postdoc at Loughborough University, London. I'm mostly working on design for policy, and I'm also module leader for the collaborative project that we have as part of the Global Disability Innovation Hub with UCL and UAL.
Thank you. Okay, so I think we have Raphael's joined, and then Julia, and then George Torrance, and then I think anybody else, maybe you can just put your intro in the chat because we're going to kick off formally, unless you would like to turn your camera on and say hello to everyone. Raphael, would you like to very quickly introduce yourself?
Yeah, I'm Raphael Tarpani. I'm a research assistant at the University of Manchester. I'm doing a project which is related to the digitalization of electronic e-health services. So I'm searching for understanding more about this, and we just started this project 2 months ago. So I'm working mostly with life cycle assessment and circular economy. Thank you.
Brilliant, thanks for coming. Julia, you can be the last live person, and then everyone else can put stuff in the chat, so otherwise we'll run out of time for the speakers. So Julia, go ahead.
Good morning, everyone. Good to see everyone today. I am actually one of the PhD candidates from University of West London, so I'll just kind of attach myself to Christus's introduction. I'm just one of the students. We are working with biomedical appliances, so this is basically the main area of interest.
Brilliant.
Thank you.
Thank you very much. So can I just check that everyone's able to see my screen, the slides? Yeah, everyone who is viewing that's great. So it's now 10:30, which was definitely the formal start time. So we'll kick off now, and this is our first workshop of this kind within TIDAL. So apart from a couple of teething problems like timings, it would be great to get your feedback at the end of this session and of next week's session, because we want to grow the network. We want it to be of service to you. So things that have gone well or not well, do let us know. Okay. So you probably already know this is the Responsible Engineering agenda setting and collaboration workshop, and the reason we decided to have this sort of agenda setting and collaboration workshop was to try and make sure that people got to meet each other, especially people that were outside this area of assistive technology or assistive living devices, that you got a chance to really understand the topic and really understand what we were thinking about when we talk about responsible engineering, get to know each other a bit, and also help us to grow the network. So the purpose of TIDAL is to improve the quality of assistive technologies and hence the lives of people who use them. And our vision is sort of wrapped around innovative, sustainable, equitable assistive technology, which is both physical and digital. And for those of you that are new to the assistive technology space, from the WHO point of view, from the World Health Organization's point of view, there's assistive devices. Those are things like hearing aids or wheelchairs or augmented alternative communication aids. And then there's the services, which could be repair services, they could be provision services, it could be financial services that help personnel, clinicians or education specialists. Those services, when the products are put with the services, then the person who needs the technology or the product gets a good quality of technology. So the technology only happens when you have the product and the service. So just bear that in mind. I know a lot of you already know that. So the aims of the workshop today are to introduce responsible engineering, and I'm going to hand over to Los in a minute to do just that and discuss its potential application to assistive technology, to help seed partnerships across the network, and to inspire innovative proposals for our responsible engineering call, and to answer questions and help you prepare to develop a bid and contribute to the community. It's sort of an informal aim that hopefully you get to know us, and then if you've got lots of questions, you can bounce them off us. We don't seem like people that you don't know. We're people that can help you develop good bids. So these are just timelines. This is probably a slide that's better just kept for another time, but the main ones are highlighted. So the 12th of May, 5 p.m, British Standard Time, the deadline for expressions of interest to be submitted. And then the 9th of June is the deadline for full proposals to be submitted. We will turn those reviews around quite quickly, and yeah, the other dates might vary slightly. So we're just lining up reviewers. Obviously, if we get sudden hundreds of applications, we might need a little bit more time to review, for example. But the deadlines for the expression of interest on the full proposals will not be changed now. So please make sure that you hit those. Okay, so it's now my job just hand over to Los. Los, go for it. You might be muted, or I just can't hear you.
Sorry, thanks, Kathy. Yeah, so just to say a few words about why responsible engineering. I think, as we all know, the climate emergency is with us now. We're living in a very difficult situation, and the science is saying very clearly that we need to decarbonise at an extremely rapid pace in order to stay within the 1.5 degrees target. Obviously, government actions can drive changes in, for example, the technology used to generate energy and so forth. But I think as researchers, we also have a responsibility and also an opportunity to consider climate issues in our areas of work. And I think the importance of the climate issue is being increasingly recognised by the research councils, which have funded projects like ours. Part of our focus through today is on climate issues. And I think for those of you who keep an eye on such things, the climate emergency and responsible engineering is becoming ever more prominent in calls coming out from the various funding bodies. Indeed, I think the urgency of the issue is reflected in our decision to focus on responsible engineering as our first call in the project. So in the context of assistive devices, assistive technologies, we can address a number of issues, and I think we've got a great set of speakers today that will help to focus our minds on some of the issues that we can consider in our domain. So issues such as abandonment reduction. I think we've already heard some mention of the frankly maybe well hidden, but frankly rather disappointing figures on abandonment, that device abandonment that span lots of different areas of assistive technologies. Waste reduction, we're going to hear a little bit more about waste issues from Mark Miadovnik. All of these relate back to carbon emissions, and I think Miko's workshop that he's leading tomorrow will help us think around how we can take a sort of systems design approach to these sort of problems. So without further ado, I'm going to just briefly introduce the 4 speakers we've got today. We have the first speaker from industry, Colin Watt, who is working on a KTP that my colleague Sibylla is leading with a company called NRS Healthcare, and he's going to talk about their focus on reducing the carbon footprint of their company, and I think that just will emphasize how important these issues are to the sector. Then we'll hand over to Sinead Mitchell, who is a lecturer in engineering at Galway, and she'll be discussing the circular economy and healthcare manufacturing. One of the talks I'm excited to listen to in particular is from Arnie Hyde, who is going to be talking about the Norwegian AT system, which I think is a model system that we can learn quite a lot from. And then Mark is going to talk, Mark Miadovnik is going to talk about work he's been carrying out, particularly related to issues around healthcare devices such as masks in the pandemic. So without further ado, I'll hand over to Callum.
Thanks, Lawrence. So good morning, everybody. It's great to be presenting today. as Lawrence said, I'm working on a research innovation project between the University of Salford and NRS Healthcare. And I'm going to be talking to you about how responsible design, manufacture and distribution practices are employed within the business.
Callum, we don't have your video, just so your video's not on. That might be intentional, which is okay, but I just thought you might like to know.
No,
there you go.
Thanks.
And I can do the slides. I'll try and follow you, but
yeah, no problem. Next slide, please. Yeah.
Oops.
Perfect. So I'll begin by giving back on. Thanks. Yeah, I'll begin by giving a bit of background about us. NRS Healthcare is one of the UK's largest suppliers of aids for daily living in the UK. Our primary means of distribution are the 22 community equipment stores which we run. So these are stocked with rehabilitation equipment on behalf of local authorities, and the equipment is stored ready for use and is provided to end users when requested. This is key to allowing hospital discharges and care to vulnerable people in their homes. In addition to the equipment stores, we also distribute our products to other local authority equipment providers, to rehabilitation product retailers who sell to customers, and direct to end users via our retail websites, Complete Care Shop, Healthcare Pro, and via Amazon. As well as buying equipment from third-party suppliers, NRS have their own in-house product design team who developed a growing range of innovative rehabilitation aids. So, as mentioned, each of our local authorities has a community equipment store. So these facilities stock commonly used equipment such as walking frames, commodes, medical equipment, medical beds on behalf of the local authority. So the process begins with an end user in need of some rehabilitation equipment, whether they're about to be discharged from hospital or already living at home. An occupational therapist will send a request for the necessary equipment to our local equipment store. The equipment will be taken from the warehouse directly to the end user by one of our driver technicians, who will ensure that the product's set up and ready to use. And when the end user no longer has use for a piece of equipment, our driver technicians will go and collect the equipment and bring it back to the store. So upon return, each piece of equipment is thoroughly decontaminated, inspected and repaired before it is placed back in stock, ready for the next user who needs it. And through this system, we're able to use, next slide, please. So through this system, we're able to reuse approximately 90% of the products that are returned to us by value and 85% by volume. To enable this, we repair damaged equipment when possible using a good stock of spare parts, but unfortunately some of the products we issue out don't get returned, whether it's because the service user is lost or damaged beyond repair, or sometimes if a piece of equipment is of too little value, it can't economically be collected and brought back. But when we do finally decide to scrap the equipment, about 95% of that is recycled. So this system really reduces waste and provides equipment at the lowest possible cost for our customers by spreading the cost across multiple uses. So NRS are also committed to reaching net zero by 2045, which is extremely challenging for an equipment supplier, as we inevitably need to manufacture our products somewhere using carbon intensive materials and processes. We've calculated the carbon footprint of all of our own brand products. To do this, we broke down each piece of equipment into its constituent materials and the carbon footprint of those materials, as well as the carbon footprint of packaging and shipping. And we're now applying this knowledge to the responsible design and manufacture of our products by reducing material content by weight, especially plastic. We're substituting high carbon materials such as plastics for low carbon materials such as bamboo where possible. We're encouraging our local authority customers to purchase higher value products made from more durable materials, so that we can get more reuses out of one product. And we're increasing the stock of spare parts that we keep to enable us to reuse products more as well. We're also looking to offer a product rental service on a similar model to our community equipment stores, but in the private commercial space. Next slide, please. So, as I touched upon before, NRS have an in-house product development team with considerable expertise in developing new rehabilitation aids. We've focused on improving the products to offer a better functioning, more durable, high quality product than previously available. We also aim to improve the end user experience with products that are easier to use and that users are more likely to pick up and less likely to abandon. So just as a few examples, on the bottom there we have our CuraCare cutlery range, which is a set of ergonomic cutlery designed with the University of Loughborough. In the center we have our Easy Fit Plus bed rail, which is designed to fit nearly all domestic bed types and uses a set of innovative fixings so that an end user can quite easily and quickly install and use the device. And finally, on the right, we have our Freestyle 3 wheel rollator, which is a lightweight aluminium rollator with an innovative folding mechanism and removable bag. And next slide, please. Before I finish, I'll just introduce you to the project that myself and the academics from the University of Salford, Sibylla and Lawrence are working on with NRS. So NRS are currently engaged in a 2-year knowledge transfer partnership with the University of Salford to fundamentally redesign domestic walking frames. So we're building on research that was conducted previously by the academics in the health sciences department to improve the safety, stability and ease of use for walking frames. Our prototype walking frames are being evaluated in a gait lab against current standard walking frames using motion capture technology and innovative biomechanics algorithms to analyze the data we collect. We've also begun testing the products with end users in care homes. So we're not able to disclose too many details at the minute because of the commercial sensitivity, but we believe we'll have a good product design completed by the end of 22. It'll be much easier to use. It should significantly reduce falls risk, and this will reduce hospital care costs and NHS social care costs ultimately. That's all from myself. On behalf of NRS Healthcare, thanks for listening. And if you have any questions, just let me know, and I can pass any on to members of the team.
Brilliant. Thank you so much, Callum. That was really great. It's great to see what you're doing with the walking frame as well. I remember talking to Loss about that many years ago. Is there any immediate questions for Callum from anybody before we? No. Yeah. There's some chats. Yeah. Go ahead, Kevin.
Yes, Callum. That new design of walking frame sounds fabulous. My mum at the moment, she's suffering falls quite regularly. And I've been trying to look at modifying the equipment she's been given. And my wife is an OT, so she's quite expert on, and there are big problems with the things that are out there. So I am really keen to see what you'll come up with to help my mum. And if you need a test rider, send it this way, please.
There we go. So there we are.
Thanks very much for that, Kevin.
Okay.
There we are. So one of the things that we hope to get is a little bit more interactivity between projects as well today. So that's great. So we're now going to turn our attention to the west of Ireland, to Sinead. Sinead, would you like to let us know a little bit more about what's been happening over in Ireland on the circular economy and the future of healthcare manufacturing?
Okay. I don't know how how the future is going to end up, but sure, I'll give it a go anyway and give you a few ideas of what's happening here. So thanks very much. Anyway, it's great to be with all these amazing people here, including the people attending. You all seem to be doing amazing stuff. So it's great to be part of this. So as Kathy said, I'm coming to you today from Galway. So it's a relatively small city in the west of Ireland, population of around 80,000, so including 30,000 students, so there's a lot of them around. So Galway is a city that's known for decades as a centre for arts, for culture and music, and it draws many people to the city to live, work and spend time here. However, it's also globally known. So the university that I'm based in, the National University of Galway, is recognised internationally as a global hub for medtech research. And Galway itself as a city, even though it's so small, is actually recognised as a global hub for the medical technology sector in general. Interesting point, Galway produces 80% of the world's stents and around half of the world ventilators from this small city here. So they've been very busy making and innovating on ventilators the last couple of years. And the sector is an interesting one to focus on in relation to sustainability and responsible engineering. So Ireland as well is quite a small country, and we could fit two of us population-wise into London. So it's interesting that such a small country has become a global hub for healthcare manufacturing, and we currently have 9 out of 10 of the global tech companies based here. We have 10 out of 10 of the top pharma companies, 14 out of 15 of the top medical tech companies globally based here in Ireland. So it's a location of choice for many US companies as a base for European markets. And so the government is also very pro-business, and the economy relies quite heavily actually on foreign direct investment, probably more so than any other European country, which is another thing to talk about. Also, there's a lot of tax incentives for companies to invert here, so which a lot have done in the last number of years. So this is a picture here of some of the stuff that we make. So we're the second highest exporter of medical devices globally. We're all of the world's supply of Botox actually comes from the west of Ireland, as well as all of the world's supply of Viagra. And we also make 60% of global orthopedic devices, apparently, and not a medical product, but it can help lift the mood. If you shake it a bit, we apparently make 70% of the world's supply of Tic Tacs. I found out recently. So, but in Ireland, we're great at that. We're great at making all these things, but we're not great at environmental performance actually. And we're ranked worst in the EU for climate action. We're the third highest emitters of greenhouse gases per capita in the EU, even though we don't have much heavy industry here. So a lot of that is based on land use, energy and agriculture practices, and the lowest land area covered by natural forest. So, and we're very slow on our circular economy as well. So we need to do a lot of work here, less than 2% circular compared to the average EU of 12%. And 11% of all the waste in Ireland is actually from healthcare. And so it's a leading creator of single-use products. So I believe that, business needs to be part of the solution to reverse damaging environmental practices in general. So for one way for industry to tackle this problem is to embrace a more circular economy model. So this model aims to eliminate a lot of the inefficiencies that are in our system that is, global of, we take stuff, we make stuff and we throw it away, in particular medical devices and single-use devices. And single-use reactors is, exponentially growing as well in the pharma industry. So in this system, there's biological and technical materials that are often just smushed together, not the technical term, but it makes it really hard to find future uses for any of these resources and materials. So the circular economy is based on the 3 principles of designing out waste and pollution. So not designing in waste, importantly. So keeping products and materials in use for as long as possible. So Colin referred to that there as well, and regenerating natural systems. So, but the question is, does the circular economy offer opportunities for companies to manage and reduce waste in the healthcare? So it has been successfully used to implement some great things, according to research, and such as sustainable procurement, managing waste effectively, safe reuse and reprocessing of some items, and new business models. And studies have shown that the adoption of circular economy principles could help companies, develop co-benefits. So reducing cycle times in production, improving customer lead times. These are all things companies want to do, and in turn increasing incomes and attracting new customers related to more sustainable processes and products. And it could lead to developing closer relationships with customers and suppliers, and it's really critical for the circular economy to do that, and opening new markets and generating higher profits. So this is despite the reported challenges in recovering value from reusable devices caused by a lack of communication between various stakeholders such as employees, waste management, staff, procurement and end markets. So the research also indicates that there are various, so next slide there, yeah. Oh, the one before there, I think. Oh, I know where you are there, sorry. We're on, what are the things related to EU? There, yeah, great. So the literature indicates that there are various eco-innovations already developed, such as design for the environment. Somebody mentioned something about that already. Waste to energy, so that's burning stuff, and product service systems that could be implemented by medical manufacturing industry to incorporate circular elements, but their implementation is very mixed. And design for any type of environmental or sustainability or circular economy or anything in the medical industry really lags in performance compared to any other industry, despite the design stage being the most important place to address these issues. Adopting waste to energy is used as one way of diverting waste from landfills and producing energy, but again, it's not ideal either. And product service systems is an instrument that could definitely support circular economy models and manage resources effectively if these systems are well designed to reduce environmental impacts. But the opportunities would need to change the business models significantly. So this is a big barrier, and some believe it's suitable for larger medical equipment rather than for other products. So industrial symbiosis could play, next slide there, in adopting many of these eco-innovations. And so this is the process where waste or byproducts of an industry or industrial processes can become raw materials for another one. So cross-sector collaborations and innovation are really needed to operationalize this type of symbiotic system. But there are limitations, in particular, if you're a small and medium enterprise, and how would you set something like that up? It's just impossible. So we all need to work together, and there are particular challenges in the medical industry compared with other sectors due to it being a high-risk field. We don't want to endanger health or lives, and there are strict, very strict regulations in place and a hugely strict culture of regulations. So that said, there are a small number of companies reportedly managing the reprocessing of some single-use devices. So there are some small pockets reported activity happening, next slide there, but overall there's a lack of research in the area of the circular economy and the health manufacturing sector in general. So in 2020 we did some initial investigations into what's happening in Ireland in the healthcare manufacturing companies, particularly looking at their readiness levels for the circular economy. So what we found was that there was little familiarity with circular economy, and particularly very low familiarity in senior roles in companies. So much of the activities that were happening seemed to be driven by lean manufacturing, actually, which is a big culture in a lot of the medical device companies here. And it's so that's focused on eliminating waste in the value chain, to save money. And these activities have probably led to a higher level of recycling levels, which isn't the most ideal option for the circular economy, and has led to a lot of waste reduction. So there are claims to have the redesign of products to reduce waste, but a deeper dive into this is needed to see what it actually refers to and whether there's actually evidence for it. So next slide there. So in rank order, the current drivers to adopt circular economy concepts are, cost savings, number one, for companies, supply chain, number three, governments and legislation, number four, new business opportunities, and five, client expectations. And the factors that are stopping the circular economy being developed, a lot of it is to do with internal prioritizations in companies, and companies aren't really prioritizing it at all. They don't know much about it, especially the senior management. Internal funding and resources isn't available. There's no policy and legislation really that allows for it much. There's no government incentives, and there's a lack of consumer perception around it in general. So next slide there. So how do we unlock this in the medical device industry. So we need some enabling policy and legislation. Companies, especially small and medium enterprises, need some financial assistance to do that. We need some better design for the circular economy, better design for trust, better design for all of these things, better design for disassembly, and we need to enable collaboration within the industry. So this is why all of these network collaborations are really important. So finally, just on reflection, so the concept of circular economy is not well known in the medical device companies, in Ireland anyway, and there are some positive personal views on circular economy from people who were involved in the study, but there's differing views depending on the company role. So original equipment manufacturers are less likely to envisage opportunities, so they seem to be more set in their ways. But the biggest driver is cost, the biggest barrier is internal, and oh, that's my time up there. And so we need to do more education, have more government support, and have some more industrial symbiosis development. Sorry, somebody's trying to ring me there. It's all happening at once. Okay, that's for me. Thank you.
Thanks, William Sinead. So hopefully has anyone got any questions on Sinead's work there, which I'm sure will, given the size of the industry in Galway and in Ireland, it is surprising that circular economy is not more established. But I think the recent research definitely gives us some pointers as to what is needed, which will hopefully be things that we can unlock in the proposals that you guys submit. So any specific questions for Sinead right now, or comments or thoughts? If not, we'll move on. I think, yeah, people are just chatting in the chats to you, Sinead. I think.
Thanks.
Yeah, so Kevin's got lots of questions. He wants to chat with you afterwards. So let's let that happen. I think you can have an internal chat on Zoom if you like. You can just chat to one another, and no one else will see that chat. So with that, I'll hand over to Arne. So we're halfway through the presentations, and we can have a more general Q&A at the end. Arne, over to you.
Thank you, Kathy.
Skipping around Europe, it's good fun.
Thank you for inviting me. My name is there. I've presented myself. SINTEF is a large independent institute. And we have a long history of research and development within the AT sector. Next slide, please. Okay, there it is. So I'm going to talk, mostly about the system, but also then gradually into the reuse aspect. There are some illustrations on this first page. Firstly, Norway is long stretched, and I always call it a small country, but it's actually 50% larger than United Kingdom. But the population is small. I guess around the same size as Ireland, 5.5 million people. It's split in 11 regions and lots of small municipalities. And throughout this long stretched country, there are 18 assistive technology centers. The system was built up from the 1970s, and from 1995 there was a uniform public and national system for assistive technology in place. Today this is organized under the Ministry of Labour and Social Inclusion. The system is based on principles of equal access nationally, which is a very important aspect in Norway, and it's funded through the national insurance, so it's a fully publicly funded system. It's also a rights-based system embodied in Norwegian law for individuals who meet the necessary criteria. It's an interesting aspect that the definition of disability and the thinking around this back in the 70s was quite advanced at the time, human rights based, but also based on the Nordic model of disability. I don't know how familiar you are with that, but it sort of captures a lot of what's in the ICF thinking and the merging of the social and the medical model. And it's called the Nordic model. So the other pictures here, I was told to talk about the illustrations, so I will do that very briefly. First is just a picture of a storage in an AT center to give you an impression of the, the size of it. There is a picture then also of one center. So these are quite large units placed around the country, and then there is a picture of what happens to all the devices that are not reused. They are destroyed and then enter into the existing recycling system that we have in the country. Next slide, please. It's the system is then organized in one system, as I said, the Norwegian Labor and Welfare Administration, short is NAV. At the bottom of this triangle, there are the NAV offices that you find in every municipality. So there are some incidents, some examples of few small municipalities organizing such an office together, but in principle, it's reachable within quite short time for every citizen in the country, and the country then, these offices then work closely together with the municipal health services and other municipal services. Then in the middle we have the centers that are often placed at a regional center. At least there is one per county, and they serve the NAV offices with expertise and also with assistive technology, assistive devices, of course. And then there is a central element there of with different competence center. For instance, one center for facilitation and participation that serves the AT centers around the country. Next, please. So this is basically a one-stop shop. I think that's the right expression in English. There's one large system, provides almost all assistive technology in the country. It's a lending system. It means that all the devices are owned by the NAV system, and private suppliers also have a role in through the tender processes, and so they are then they can then offer their products to the NAV system and either get accepted or not. So the private market outside of the centers is marginal, almost non-existent, although there are examples of, I mean, you can go and buy a wheelchair from your own pocket, but people hardly do that. But services are then based on assessment and decision at the level of the municipality. So someone in need or who is identified with a need through the health services, for instance, will then be assessed and interviewed by normally an occupational therapist at the level of the municipality. And then there is an application system goes through the AT centers, and then the devices are handed out at the municipal level. And the users then enter an agreement with NAV and describing the need and commit themselves to treat the device gently, and then the device is supposed to be returned when it's no longer in use. Next, please. It's at the level of the municipality, there is the assessment process, the application, the agreement, as I mentioned, supply and return. There are also some functions at the hospitals when it comes to hearing devices and orthopedic services. And the centers, AT centers, they receive then all the returned ATs, and they do a cost-benefit analysis of whether it's worthwhile to repair and put back into the storage and then be handed out again to new users. Next, please. And here are some figures on distribution of devices. The total number of devices and users in the first figure. There were in 2021 480,000 devices, with a slight increase from 2014. A number of users 156,000, so it means that it's around three items per user. The percentage of second-hand handed out was 35% in 2014 and dropped to 24% in 2021. I talked to the NAV people the other day just to get an explanation of that drop. They didn't have it, and they adopted their own figures and said also that it's sort of moving up and down a bit. So it is around 1/3 over the years. And yeah, sorry, I was going to comment on the last one. So the last graphs shows the value of the second-hand devices, also with a drop, of course, then from 2014 to 2021, but it's around 700 million NOK, which you can divide by 10 to get it in pounds. Next, please. There are some I mean, there has been a very comprehensive evaluation of the AT system in Norway recently, actually two, one from the National Board of Audit and also one additional from Research Institute. And the conclusion is that we are, quite content with the system. It's a very generous system, and it's rights-based. So there are some issues around overusing devices, of course. There is great expectations for the current digitalization of the whole system, which is almost already in place, but it's quite recently. This is will give a registry of all ATs supplied by the AT centers. All the application will go through that system. There will be a lending history at the individual level, and there will be full surveillance of storage at any time at the 18 regional centers. So this can, of course, be very useful information for running these centers in a even more economic way, because that's sort of the flip side of the generous system, that it also draws a lot of resources. We have introduced, we have introduced also something that I've translated to user passport. Not sure if you use the same term in English, but it's for a certain segment of users that have long-term needs and are qualified. They can have a so-called passport. It's a picture to the right of that passport, and that gives them rights to actually order directly from the AT centers themselves, instead of going via the municipality. And that's one way also of reducing time for applications and saving money at the municipal level. There is a system of individual plans, which has more or less the same function, where you can, in that plan, sort of decide what types of devices this person can order directly or not. The NAV system has set the target for reuse and repair, and that's around, split into two different categories. For some categories of ATs, it's supposed to be around 50%, and for others 15%. But altogether, there is a target for 50% reuse, and of the 18 centers, so far is only 1/3 that actually has reached that target. But that's, yeah, so they're working to get that improved. I think that's the final thing on technological development. Can actually have, two sides here. One is that new products are coming on the market all the time, and that sort of hinders reuse because people tend to want the new products, and the new products are often also better than the old ones. And the other thing is that an interesting aspect is the sort of merging of mainstream technology and assistive technology, and how this will impact on a pretty well-functioning AT system as we have it now. Yeah, thank you. Didn't hear a pling, but I guess I was in time.
I think Sinead was timing herself. I haven't been really a bit flexible. She was just being very careful. So thank you, Arne. I'm not sure if people have questions directly. People have been quite quiet with questions directly, but they seem to come in the chat sort of 10 minutes later. So is there any direct questions for Arne?
Hi, can I ask a question, Arne?
Yeah, go ahead, Rafael. Yeah.
Hi, I'm Rafael. I'm a research assistant, and I'm working a project here in the UK, University of Manchester, and we are doing life cycle assessment, circular economy of electronic equipment in independent living schemes. So I'm just curious, maybe you went a little bit fast in the part that you mentioned the electronic equipment you mentioned in your presentation. So could you give a little bit of an overview of what are the electronic equipments you use for assistant technologies? Yeah. A little bit more the details if you can.
Yeah, I don't think I can on the spot. Sorry, I mean it's really I mean it's a full range of assisted technology, whatever you can imagine in a way. But no, I don't have the full overview from the top of my head.
No, that's okay. Maybe I'll contact you later because I started 2 months ago, and that's I'm more into life cycle circular economy, and I'm starting this with electronic. And I found very interesting the part you mentioned that if it's worth or not to recycle or to reuse or
yeah, please do that. And you know, if I cannot answer, I can find someone who can answer. And but I mean that system of you know, that decision process is also quite complex and requires, you know, there are expertise specialized in doing that assessment. Yeah. But I also know that it's sort of skewed towards certain types of devices, and for instance beds and walking frames and you know, things that are easily repaired and or don't need repair are mostly reused, but complicated ATs, of course, that's another matter. Like cars and electronics takes quite thorough assessment to know if it's worthwhile or not economically.
Yeah, that's something that I would definitely need in my project now, and I'm just starting to look at it, and it's very interesting. So yeah, thank you very much, and I will keep in touch. So
please do that. Please do that.
Very interesting for me and maybe for you. Thank you.
Thank you, Rafael, for that question. And Sinead and then Mark had a follow-up question. So Sinead, do you want to say your question, or are you happy to leave it?
Hi, my question was similar to Rafael's there for Arne about when you're doing the cost benefit analysis. Do you include any variables related to the sustainability at all there? So it was a similar question that Rafael had.
I think this is basically you know, assessing how much time is needed to repair and how much that cost compared to a new product. But there is a pressure from the from above, from central in the system, that it shouldn't only be economic assessment, but wider than that.
Yeah. Okay, that's great to hear. Yeah. Thanks.
Thanks. And there's more questions coming in from Mark and Loss. I don't know if you want to jump in or if you're happy for Arne to answer. Go, Mark. You've unmuted.
Yeah, just to follow up. I mean, you know, this is such a great system you've got going there, and I just wonder if you work with the companies who produce the AT. at the early stage of development to say, okay, well, here's a sector where we think these innovations are going to really help our users, but we also want to make sure we help the environment. So we hear a set of guidelines for developing new AT so that it fits into our system and is more repairable and more recyclable end of life. Is that a kind of working practice that happens in your system?
I think the answer is no, although there might be, I mean, there is a lot of communication and negotiation between the private industry, of course, and suppliers and the system, because it's really if suppliers are not getting into the assortment of the AT centers, they lose. So it's and they lose money, and it's sort of that's a problematic aspect of it, in my opinion, that the suppliers and the producers are so dependent on that tender process, and they cannot get sort of advance permissions to start production and then expect later on to be admitted into the assortment.
I guess it's Sinead's point, isn't it, about the bottom line is the business case for these companies it's sort of in conflict with some of these environmental goals, and in aligning the two is challenging.
Yeah.
It's interesting, Mark. So it reminds me of the Paralympic and the Olympic procurement processes. So everything to do with inclusion was embedded in at the procurement stage. So when people wanted to procure the advertising rights, or procure to be the builder, or to procure to be anything, they had to demonstrate their commitment to inclusion. So, for example, having 15% of their workforce be disabled people, as an example. So it feels like there's a need at that very top level to build into the procurement standards, that drives then the behaviour, because if companies are, if it's not in their financial interest, then it's quite difficult for them to prioritise, especially Sinead said within the SME network. If you're a small company, it's quite hard if you're still trying to just keep afloat, maybe. I see Loss as a question as well, Loss, and then Matthew, and then we're going to come to your talk, Mark. So get ready.
Thanks, Kathy. I'm really curiosity about how, related to the previous questions about procurement, because I think the AT sector has a constant challenge of lots of new devices coming onto the market all the time, and I guess that relates back to the circular economy about how do systems such as the Norwegian system decide when to upgrade the technology that's on their books, and I can imagine that's particularly difficult in the AT sector, where clinical evidence of effectiveness of new devices is often lacking.
Yeah, I think my only comment to this is that these decisions are centralized. There is a unit at the central NAV that actually makes those decisions, and I have very limited insight in their thinking around that.
Yeah. Okay. Thanks.
Matthew, did you want to say something?
So it's just a quick question. So other people have brought up like electronic devices and high environmental impact assistive technology. So I was wondering how, when you talked about calculating the cost of repair, how that's actually done, because with some devices, or with any, I would assume with the majority of electronic assistive technology, there's various parts of the device which are effectively going to last for much longer than others. So the cost of repair isn't necessarily going to be the same depending on who does it. If the manufacturer has a cost of repair, that's potentially going to be vastly different from somebody outside of the manufacturer. So I was wondering how that's calculated.
I can't answer to that question. I think these AT centers are quite well equipped when it comes to also with expertise. So their calculation is based on what they are able to repair, at these centers, and I guess that's another limitation, that for some of these complicated things they are not actually, they don't have the competence to do it. So then it sort of diverts into the relatively simpler things to repair.
Okay.
Then that's my understanding of it.
So is there any opportunity then to actually are parts then just sent back to the manufacturer to see?
Yeah, I think for cars they actually do it.
Yeah.
And that's also a big part of the budget, of course. And as far as I know, there is I think they send it actually to a place, an industry in Germany that actually are specialized in doing that.
That's really interesting. Yeah.
But I mean that sounds very expensive, so
yeah. No, it's interesting.
Brilliant. Thanks, everybody. So I'm just going to move on now to our last speaker, to Mark, to let us know what's been happening in the world of plastics and masks and PPE. So Mark, over to you. I'll just move the slide. Give me a sec. There we go.
Hello. Yes, hello everyone. Yeah, Kathy asked me to just talk a bit about the work we've been doing on plastics. It's not directly related at the moment to the AT world, but and I think it's a good opportunity to sort of talk about the way in which you can approach a circular economy for any product. And I wanted to just give an example which we were involved with and pushed forward when the pandemic hit 2 years ago, which was we quite quickly understood that masks were going to be a big deal, and so the widespread deployment of masks is a sort of interesting example of how to balance the different environmental impacts with the health impacts. And so I just want to go through a little bit on how we approached it. The diagram, you can see it now in front of you, is just to illustrate, I mean, plastics as a sector in the UK, how big it is and how many different uses plastics has in agriculture, manufacturing, construction, household, and so on. I mean, you're probably all aware of this. Anywhere you look, what you're wearing, you're actually wearing 67% plastic. That's on average, most people in the West. So there's this idea of a sort of systems approach, which takes you. This diagram on the left has the kind of sources, which are mostly petrochemicals, so mostly oil and gas, but there is small amounts of biomass being used now to create polymers, and then that is fed into polymer production, and then that, once you have the polymers like polyethylene and polypropylene and all these different types of plastics, and of course the range of them seems miraculous and confusing, and it's not just because they're kind of arbitrary, it's because they all have different properties, right? So they have different elasticity, or in many cases the reason for choosing them is because they have good mechanical properties. They're like tough and relatively strong, easy to color, easy to handle, but they're also, from a manufacturing point of view, can be put into a mass manufacturing plant. And in the case of packaging, for instance, which is 70% of the plastics that go through the system, these things are being packaged, one every 10th of a second. So it's not just what the properties of the material are, it's how they fit into the system. Anyway, so then you get used and you go into our lives, and then they get, well, what happens next? Answer: until quite recently, most of it got put into landfill. Then there was a move towards incineration and recycling. And at the moment, if you're asking the question in the UK, how much goes through the system? Well, it's 2.3 million tons of plastic that goes through the system every year, of which 44% is sorted for recycling. Now, that doesn't mean it gets recycled. This is also, and I'm sure a lot of you on the call know this, but the words and these terms have very specific meanings. So when people say a 44% recycling rate in the UK, what they mean is it's sorted for recycling. That doesn't mean it gets recycled, and it doesn't. Most of it doesn't get recycled, frankly. The 48% of it is going to incineration at the moment in the UK, and the rest is going to landfill. So there's a move away from landfill, which is very welcome, but still we're a long way from having a circular economy in which most of this valuable stuff is put back in the system. At the moment, loops that take you from the right hand side back to the beginning again, i.e. it is proper recycling of those polymers, is 0.6 of a megaton, which is about 22%. We have something called the plastic pack target in the UK, which is by 2025 that 70% of the polymers going through the system will actually be recycled. So that's plastic packaging. So that's not all the plastics. And it's quite, I mean, it seemed at the time when it was set back in 2018 as quite an unambitious target. But as we get closer and closer, and you see that just how hard it is to shift a system like this, it now seems will be quite an amazing achievement. The other bit of the target is that every piece of packaging you buy in the UK by 2025 will have 30% recycled content. And this brings us back to the economic point that if you don't insist on this, and this is legislation, then what happens is that there is no market for recycled content, because the recycled plastics cost more than making it from virgin plastic, and often they have slightly worse properties, although that's not always the case. And so you need to make a market for the recycled content and insist on it. And so that then means that it's worth a lot, and then that invests in the system, and the system gets more efficient, and it catches up. But still, as you might imagine, 30% by 2025 is not really fast enough if you think about where we really need to be with the climate emergency. So it's progress, and I think it's great that we've made this sort of step change in progress, but it's not nearly enough or fast enough. Next slide, please. Oh yeah. So when the pandemic came along, face masks, we suddenly realized, okay, everyone's going to have to wear a face mask. It seemed clear that, to us anyway, that it was a very, even though the evidence at the first was sketchy, it was a preventative measure that was going to be adopted by countries, and indeed was adopted by lots of countries, most countries in fact. But then you had a choice as a country, like, how do you protect your citizens? Do you insist they wear single-use masks, or do you insist they wear reusable masks? And if you're going to do either of those things, how do you provide them, and what are the environmental impacts? And I've just displayed up here a few of the different types, and they go from the single-use type all the way through to reuse, and the reuse types have different levels of protection, so FFP2, FFP1, and so on. And these describe how many particles and how smaller particles they filter through. And in a way, especially with the kind of homemade canvas ones, which were the least efficient but were encouraged, the question was, well, actually, are you protecting your citizens enough by insisting they wear these? And should that have been clearer? But anyway, so this is the basic overview. Next slide. And then the question is, well, how do you assess whether a single-use mask made of 3 or 4 layers of different polymer types, which is destined to be disposed of, and in fact in hospitals is disposed of in clinical waste, is a better or worse in terms of its environmental impact than someone making a cloth mask at home and reusing it several times and washing it, and it lasts them a year, or maybe four of them last them for a year. So how do you assess those two things? And we use this thing called a life cycle assessment, and this is a method which is evolving the whole time, but it is really about drawing a circle around the manufacturer, like I showed at the beginning, the manufacture of every single component, how much energy it costs you, but not just that, the water usage, and things like how much fertilizer in the case of growing cotton, and how that affect the soils. So there's all these different measures and data which we have in our databases that will give you the impacts, environmental impacts of all these things, the CO2 emissions in the air, but not just the CO2 emissions, the methane emissions, and so on. And you want to look at that for all of the stages. So production, transport to the UK, because most of these things in the single-use case were being made in China or Turkey. And in the case of the cloth masks and the other types of masks, we analysed different bits of the components will be made in different countries. So you have to assess all of those, the manufacture and the transport and the assembly, then the use phase. So in the case of single-use masks, the use phase is a day or maybe a few days. People started to reuse them after a while. In the case of a cloth mask, it's the washing, and you have to consider whether you do manual washing or machine washing, and it turns out that makes a big difference. to the energy usage, and then of course the energy mix. So if someone's using renewable energies, that's going to have a different environmental impact than if they're using electricity, which is from fossil based. So it's a complex set of things that we have to assess. And on this diagram, I'm just showing different scenarios where you have to sort of assemble what is inside the system that you're going to consider and what is external, which you're not going to consider. Next stage. So these things take a long time. Data is hard to get, and often you're sort of making some assumptions. And then you have these things called scenarios. So just to show you, we had a single use scenario where at the top here, where we're saying, well, you're going to use 365 of these a day because you're going to use one a day. And we're comparing that like for like with someone who's using a reusable cotton mask, which they may have made themselves or bought themselves, and they're doing 2 masks in rotation. So one day they wear it, the next day it's being washed. And we're also going to compare that with the reusable cotton masks where they use it with a disposable filter, which gives them better protection. And we're also going to use one where people do 4 masks in rotation and so on. So we have all these different scenarios, and some of the scenarios involve machine washing and some of them involve hand washing. And you think this is a joke because it can't make that much difference, but you'll see in the data it does, which is mad, but it's true. Okay, so yeah, next slide. So if the kind of data that comes out of this are these kind of bar charts, and we've got tons of them, so and I'll give you the link to the paper in a minute, but basically what's really interesting is on the left here, the first bar chart you see is mostly yellow and a bit of orange, and what that means is that transport to the UK, and the vertical axis is climate change impact, which is essentially effective CO2 emissions. So the effective CO2 emissions for a single-use mask, you use it every day, 1 a day for a year. Most of it is dominated by the transport to the UK, even though it's shipped, and that's a very efficient way of using fossil fuels, but it's still dominating, and they're shipped by the billion. So, I mean, we're using 1 trillion of these a day globally. So it turns out actually that moving things across the world in order that someone in the UK can use a single-use mask is not a very good way of trying to reduce our CO2 emissions. And then the other bit, the orange bit, is the mask manufacturer. So that's its big impact. Now, if you compare that with the best other scenario, which was reuse a mask, with a cotton mask, and it's a machine washed without a filter. And what you have is a much lower bit of orange, which, well, it's actually quite similar to the amount of energy used to make a single-use plastic mask is very similar to the amount of energy using a cloth mask in our scenarios. But then you can see the transport to the UK is much lower. And then other bits like the light blue in this is 4 from the right, 4 from the left I'm looking at. The light blue use phase is almost 0 in the single use case because you're not cleaning it at all. But in the case of this cotton mask, it's being machine washed with your other washing. And so it's significant, but it's not big. Now compare that with people doing manual washes, which are the next 2 columns in between, and the light blue is very large. And that's because manual washing basically uses up a lot of energy. So little changes in the way that you do things, when you max it out of a whole population, 60 million people, or in the world, 7 billion people, have huge effects. And I guess that's so designing things not just for their transport, right? So local making can have a huge effect, as we just seen, and also designing it so the use phase is low energy and low impact. And this is just the CO2 emissions. If you go to the next slide, you'll see that we compared not just CO2 emissions, but many other environmental impacts. So at the top, so it's a whole set of columns, and it's quite confusing. So I'll just take you through it. The columns are the different scenarios. So the first column is the different types of environmental impact. The second column is scenario 1, which is the single use. And red means bad for the environment, and it's the worst of all the scenarios if it's colored red. And green means it's better, not best, not brilliant, but better. And it's the best of all the scenarios. So you can see that the fourth column, which is reusable mask machine washing, is better for the environment in almost every case, but not every case. And that's because land use, for instance, to grow cotton is bad. And in fact, turns out that if you were to use a single-use mask, which is fossil fuels, like oil, it scores highly on land use because there's not much land you have to use up. And so this is the other thing to really think about when you use LCAs, which is that when you look at all the other different ways of assessing environmental impact, like water use and ozone depletion and so on, which we've listed here, and I won't go through them all. But the important thing I think to say is that it's very rare that you're going to have one thing or one product that wins on all of them. And so you're always going to have to sort of, you're always looking at a comparison, a best case, which is about a qualitative judgment, or in fact, a political judgment a lot of the time, because we might say, well, it's fine, we don't mind the land use thing. But the people who are growing the cotton, they may really object, right? Because their land could be used for food, and their water usage could be depleting their whole community of having fresh water. So it's political as well, and it's global, these LCAs. And I think that's a really important part of what they're used for and should be used for, which is to be fairer across the whole world, not just for us to pat ourselves on the back in a particular place where we might say we're doing well because we thought about it and we've got it, we're using the reusable case. Okay, yeah, we've got to go. That's it, I think, isn't it? Oh yeah, so if you want to have a look at the paper with all of this data, and it's hopefully it isn't just about the LCA, it's also about and I guess that's another point, which is it's a multidisciplinary look at the whole thing. So it's about the health outcomes, it's about the behavior changes, how easy it is to persuade people to use reusables, which turns out to be not so easy. And the big thing to come out of this for us was that even though washing at home with a machine is the best outcome, actually in practice, very few people did wash their masks. They put them in their pocket, they use them the next day, keep putting them in their pocket, use them the next day, and no one has done the data on whether that actually turns out to be a health disaster. So there's a lot more to consider here, but I just wanted to give you an overview of what we did and how hard it is, how complicated it is just for a mask, just to do the mask analysis. Anyway, I'll stop there.
Thank you, Mark. Is there any questions for Mark or comments? I see Sibylle thinks it's very interesting. I thought it was very interesting, even though I've heard you talk about it before. I hadn't appreciated it. Yeah, go on, Ian.
Mark, thank you very much. This is very sobering and just basic reality. And you see it in my comments already. I think we should use the same analytical model for an X number of assistive technologies on a global scale, because you say, well, actually plastic is not one of those for this meeting. However, an awful lot of lower limb prosthetics in upcoming economies are just made from polypropylene. So I think that alternatives and just saying people, actually, if you do it like this, this, and this, it is better for everybody. So thank you for that.
Yeah, thanks for that comment, and I appreciate it. And I think the other thing I'd add to that is the local. When you look at the transport and as you say, this production of waste from one place into another person and into another country, and then it's abandonment. In the case of plastics, it's really severe. And other materials too. And in the case of AT, you've also got this benefit. If you do local repair and local production, you have a local economy, and so you have local. So there's actually a lot of benefits when you compare it with this sort of globalized model of we're going to make them all in China and we're going to ship them to different countries. So I think, and Kathy and I are working on this in other projects, but I agree with you entirely.
The other thing, because what we see now happening in assistive technology on a global scale is that a lot of people talk about appropriate technology. It should be locally made, and it should be this, and that. And personally, I think what we should keep at the highest value is functionality and making absolutely good stuff. Yeah, and often you see that when you're using local materials like natural fiber composites, then you get a cheaper product, but the performance of the product is not necessarily increasing. So performance of a product is key, and then we should look at which methods are the best way of producing that. That's my personal opinion.
Yeah, I think it, and going back to the LCA, like there's so many things to consider here, aren't there? And what is our priority? Is it environmental impact? Is it the clinical outcomes? But they'll start to. There are different decisions that will prioritize one or the other, and that that's where it becomes tricky, right?
Oh, this is very interesting. Thank you very much.
Yeah.
Mark, there's a very technical, well, not very technical, but there's a specific question, let's say, from Mazir, who's talking about it's slightly confused between scenario 2 and scenario 4 for cloth masks. I don't know if you want to quickly read it.
Yeah. Oh yeah, okay. Scenario 2 is they're both for cloth masks, yet the manufacturing CO2 is higher for the machine wash over the hand wash when these have no bearing on the mask manufacturing. How are the manufacturing CO2 levels of the mask different? Okay, so 2 is reusable mask, manual wash without filters. I think that's with filters. Sorry,
can you hear me?
Yeah, go ahead.
Yeah, hi. A great talk, by the way. Really well articulated the multifaceted nature of the challenge here, that it goes just beyond the recycling element itself. But I was just looking specifically at the orange section, which is right at the bottom, which was for the mask manufacture. And if I understood right, both of these are reusable masks in S2 and S4, yet the height of the orange section in S4 is larger than the other one. One would
you're right.
assume that they're both the same, should be the same.
Yeah,
height.
that is a weird anomaly. You're right.
I think you're right. I think you're right though, Mark. I suspect because the 2 orange bars of scenario 2 and scenario 3 are the same level, I suspect that those 2 should be with filters or without filters.
I think
and then scenario 1 or scenario 4 and I think it's the filters that makes the additional, and it's just it's an incorrect label on the horizontal.
I think it is an incorrect label, but well spotted. Thank you.
That's okay. Sorry about that. I mean, I was just wondering if that was highlighting a normalization of the numbers between the different subcategories, or if that was.
No, that's not the intention. They are meant to be on the same scale. Yeah. Thank you for that. It's I'll go back to that and have a look at that.
No worries. Thanks for the clarity there as well.
Brilliant. Well, thanks a million, Mark. There's Sinead's going to be doing LCAs for lightweight drones for service delivery or delivery services. So Kevin, you've just asked a question on funding process. So as it says here, at the moment, just in this particular scenario, we can't answer questions on specific individual projects, just in this environment. But I've captured your question and we can answer it outside of this. So we will answer that. But I can answer questions, or I'm hoping the rest of the gang will help me answer questions more generally on the funding process or on eligibility, like what's in and what's out, because it is. You must remember that this is Engineering and Physical Sciences Research Council, so money. So it's technology readiness levels 2 and 3 and kind of 4, if you like. So ideas and things of proof of concept type funding, which must address the healthcare technology challenges more broadly. And that's our overall remit. So whilst we care very much about responsible engineering overlapping with healthcare technology and specifically within assisted living devices, we must hit that funding, that funding area call. So even, for example, in Callum's work, Loss, you can probably comment, but in Callum's work, was it NIHR funding, or I can't remember.
It's KTP.
It's a KTP, which is slightly different, right?
Yeah.
So it's more like that technology readiness is slightly further along or slightly more applied. So it has to be sort of basic research for EPSRC core funding. So so is there any, Lost, did you have something to say? Sorry.
No, I'm just here to chip in if needed.
George, who's eligible to be funded? Yeah, so it's the standard. There's a frequently asked question on the website. If you go to it, the standard EPSRC rules. So that means that the primary lead must be a UK-based higher education institute, effectively somebody who can get money. But charities can be part of that. So can people outside of the UK. However, if you're a developed country, you can't get money. So, for example, Arne or Sinead or somebody could be involved, but their institution couldn't get any money from the UK. However, if there was a collaborator from, say, Uganda or lower middle income country, then they could receive funds. But the funds must initially go to a UK-based higher education institution. that answer that? It seems to be the standard question. So, but thank you for that, George. So things like market research, and just not going to talk about your specifics. So it's a new mouse thing; it keeps just moving no matter what I do. Just to answer there was a question there on market, Kevin. So market research wouldn't fall in under basic engineering and physical sciences research. That's something that the Research Council doesn't fund. It's outside its remit. Any other questions? So I suppose if there's no other questions, we've got 9 minutes left. I'll move on to what's going to be happening tomorrow, maybe, and just let Miko say a few words as well, but if he's still here. But tomorrow's going to be way more interactive. That's the first thing to say. So today was quite us just trying to set the scene and set the agenda and try and maybe go a bit beyond assistive technology and assistive living devices, so that you could kind of see the remit of responsible engineering and maybe understand a little bit about how responsible engineering is captured sometimes when you know that might not be your core area. But Miko, tomorrow we have a bit more of an interactive session planned. Would you like to say a couple of words about that so people can get themselves set for those who can join us?
Yeah, thank you very much, Kathy. So tomorrow, what we will try to do is to start at 10 o'clock. In the morning and not 10:30. Is that correct, Kathy? That we can. Yeah, it's correct. Yeah. So and tomorrow's agenda is much more hands-on. So what we will do is we will start off by a little bit of inspiration. Some of the members from IDI that are here, the Institute for Design Innovation, will be talking a little bit about some of the perspectives coming from the human-centered design perspective, and especially the question of desirability. What we notice is in very many cases that technology and business cases are really important, but then you also want to address the human factor on it. You want to address what is so desirable in this. How is it? How could we configure people's desires into this? And what we were proposing to do tomorrow is to look at it from a product service system perspective. How do we understand these as systems that actually have both products but have services and are centered around users and things like that. So what we will do is we'll have a short inspirational session in the beginning, and then we will have around 45 minutes, 50 minutes of breakout rooms around 3 sort of key issues. We want to look at some of the ecosystems around these product service systems. We want to try to understand value creation, and we want to also understand how do you actually generate an offering that is interesting. So we want to bring people to discuss these thematics around 3 streams of thinking. We'll have three groups working on these. Each one of the groups will be facilitated by one of the IDI members, and each group will have also the title seniors involved in all of them. And we'll make the invitation still later today, and we will share also the slide deck for tomorrow still later today within the same link as you had this one. So we'll update the link to those slides. And right at the very end, then we'll try to sum up our learnings and from that day, and try to address some of the key issues and observations that we will generate tomorrow as groups. So we will be sharing across the groups after the breakout sessions. Any questions at this stage? Anything from you, Kathy?
No, nothing for me. I was just answering a question in the chat from Veruna, who's asking about AI, for example, and we have subsequent calls which will be around artificial intelligence and data. So we have a number of different themes within the TIDAL network, and it just so happens that the first call is focused on responsible responsible engineering, which does have a bigger focus on products because of the carbon costs of those, although there's quite a lot of carbon costs in data storage as well and cloud computing, but we haven't focused in on that. So subsequent calls will have, we'll be very focused on, we'll have, instead of saying Mark Miadovnik, we'll have someone who's an AI specialist. So you should see them coming up very soon, actually. But as for tomorrow, hopefully we're all set, and it will give you a chance to get to know each other a little bit more and maybe develop some ideas with some teammates, people that you know or don't know. Yeah, but I think that's all from us for today. So thanks to the speakers. Thank you for taking the time to join us. It's been a very informative session. I've thoroughly enjoyed it, and I hope that everyone else has done too. So I'll just say thank you, and then I'll close. The video will be available soon once it's processed and done, whatever it does.
Yeah.
Okay, everyone. Thanks a million.
Thank you.
Take care.